Good morning. I like the fog machine. Never had a fog machine before at a cybersecurity event. So I'm going to spend a little bit of time with you this morning talking about sort of the three evolutions that Mark highlighted and how we see this really changing fundamentally what we need to do to secure our networks and how that evolution is going to continue for quite a while, I think, because the attackers continue to evolve how they're coming at us. And so everything that we're comfortable with and everything we know how to do to secure our networks is probably out of date. When we need to continue to think about how we change and advance and shift what we're able to do to make sure that we can keep up with all the craftiness of all the bad guys out there. My name is Scott Stevens. I'm responsible for our global systems engineering team here at Palo Alto, and I'm the CTO for our service provider theater. So I spend most of my life on airplanes, talking to a lot of people and trying to understand what are the latest challenges and how do we help address those problems. This is the reason we're here, understanding technology and how it's part of our lives and how it continues to change. And I think, if we think about this in lots of different ways, the challenge that we're all fundamentally dealing with is the fragmentation of trust. Right? We hear about breaches today, and we think that's normal. And as Mark said this morning, I think we can do better than that. The fact that all of these networks are vulnerable is a testament to the creativity of the attacker and perhaps the lack of creativity on our parts and how we protect ourselves. We've had lots of interesting opportunities with how what we get to do is evolving. It's good for the attacker, it's good for us, it helps us with our business, but it creates interesting new vulnerabilities as the types of things that attach to our network change rapidly, and the places where we store our data continues to evolve. So if we don't, the ways that we used to think about a security moat, which is I feel like I'm standing in front of here, to protect our infrastructure and our data, the moats are gone, the perimeters are gone. Your data is everywhere. And so as an attacker, I don't necessarily need to find one way into your network. I've got 10 different vectors that I can try and leverage to get after your data. I mean, we need to be good 10 different times in keeping them out. So let me talk about the three evolutions. Mark went through this in about 5 minutes to talk about the application framework. I'll spend a little bit more time than that and be a little bit more specific about these three evolutions. This slide has been around as long as I've been at Palo Alto Networks. And this has been the problem where it all began, I think. And for me, this is interesting. This has been what security was for the longest time. This is the multi-vendor defense in depth strategy. This is the UTM architecture. But this is basically saying, when we we started 20 some odd years ago with the firewall, and we said this will keep the network secure. And then threats started to change, and we had to bring in IPSs and IDSs to take care of problems the firewall couldn't deal with. And then the web took off, and we needed to figure out how to handle port 80 and proxies or web gateways because we had threats from the web side that we couldn't deal with on the IPS side or the firewall side. And then malware really took off, and we had to figure out how to find malware and deal with that and figure out then how to build these interesting feedback loops. This happened to us. This wasn't something we tried to do. We didn't try to build a layered approach to security. It occurred because each layer before it was failing at something. And when Nierzuk founded the company 13 years ago, he said, that's broken. We need to do something different because the sum of security is not stacking a bunch of disparate technologies on top of each other. Security should be holistic. We need to do all of these things, but we need to do them in a consistent, integrated way, not by stacking them up. And for me, the biggest frustration here was security lacked a feedback loop. Routing has a feedback loop. We build our routed networks, and if something happens in the network, routers talk to each other, and they reconverge. Switches have feedback loops. But there's nothing here that had a feedback loop. I think that's ridiculous. If anything required a feedback loop, it's security. We need to adapt real time based on what just happened and what new attacks have come out. And so lacking a feedback loop, we ended up with an architecture where the feedback loop was you. It was manual, it was time intensive, and it was slow. So you'd find something through one tool in your security posture, and you had to figure out what to do on every other tool that you have so that you could update your posture. And that would often take days or weeks. That's a long time to give somebody access to your network when you've discovered a risk. And so the first evolution that we focused on basically did two fundamental things from a network security perspective. First, we stopped being disparate in that posture. And in doing that, it allowed the feedback loop to come into existence. If we can detect the unknown, determine what it is, and make it known, we can then update our security posture. And updating your security posture means touching multiple different components. I need to update my inline AV. I need to update my URL rules for C2 and downloads. I need to update my DNS rules for C2 and downloads. I need to update my outbound IPS signatures to deal with C2 SIGs. Those were multiple different products in that old world. There was no protocol for multiple different products to talk to each other. There was no feedback loop. So by collapsing that and integrating that, we made the opportunity for the feedback loop, and then this whole problem of how do we find malware became a cloud-based solution, and I'll talk more about that in a moment. So evolution one simplified the network problem, gave us a feedback loop that the industry was lacking, and allowed your security posture to update for you, so you no longer had to be responsible for doing that. With evolution two, we took that feedback loop, and we took that integration from a network security perspective, and we extended it now to include the endpoint and what is happening in the cloud. These things should be talking. The network and the endpoint being independent of each other, that makes as much sense as a firewall and an IPS not talking to each other. We need to have an integrated feedback loop between all of these things, because if I find a piece of malware in the cloud in Brazil, within 5 minutes, I'd like to be protecting the endpoint in Australia and the network in Germany. Finding malware and dealing with it, it doesn't matter where it is. Once we know about that malware, we need to act on it, regardless of where it existed or where we found it. We need that consistent view, that consistent feedback loop. So you know, maybe my network updated, but my endpoint's separate. Well, is my endpoint secure now? Well, we don't really know. Our feedback loops are disconnected. So if we look inside of the components of that feedback loop and what was built to make that happen, Wildfire was the really disruptive technology. 6, 7, 8 years ago, as this was being built and brought to market, Wildfire, the cloudifying of finding unknown malware and taking action against it was brand new. Autofocus, I'll talk about it for a moment here as well. Autofocus gave us the cheat sheet. If I found malware, it's one thing to say, hey, you've got malware in your network. OK, what does it do? I don't know, it's malware. How dangerous is it? I don't know, it's malware. That's not a contextual conversation. To understand exactly what kind of malware you're dealing with, what are the risks, how often have we seen it around the world, what industries is it part of, that becomes a very interesting conversation. So putting context to the attacker and what they're trying to do becomes really, really key. Wildfire is interesting because it's created this feedback loop. We're adding customers every quarter, and basically, what finding malware is about, this is a big data analytics problem. I need to source data from all over the world, and I need to quickly determine if what we found is malicious or not. And then I need to act on it. And so what Wildfire did is cloudified this. It said, I have a distributed set of sensors globally who are working to the common good of finding a piece of malware once and keeping it out of everybody else's network within 5 minutes. Right, so I don't need to find it over and over and over again. If you go back 6 years ago, the way that we found malware was every network had a malware detection capability, or every network that was looking for it. And so we'd find a brand new piece of malware thousands of times because none of this was connected. Again, didn't make sense. The feedback loop needs to be global in nature. So we need to harvest lots and lots of data. We need to analyze it. We need to discover what's malicious, and we need to act on it so that it can no longer move. Make the unknown known, and we can solve for it. And with a 5-minute feedback loop, the unknown is allowed to be unknown for 5 minutes. The bad guy has to move really fast before you neuter any piece of malware that's shown up in your network. Interesting things that we've discovered in Wildfire recently. We find about 30,000 brand new, unknown pieces of malware every day. So we have to push all of those signatures out, and again, all of the different AV, URL, DNS, C2, make sure we update the security posture every day. Portable executable has been the most prolific malware type for as long as I've been looking at malware. Interestingly, on most days now, APK is the second most prolific type of malware. When I started tracking malware statistics 4 years ago, it barely registered. DLL was number 2 and had been number 2 for a long time. DLL is number 3 most of the time now. Bouncing DLL and APK dance back and forth depending on whatever attack campaign happens to be happening at the time. And new to the malware world is ELF. Right? All of the Mirai and similar types of IoT-based attacks have become quite interesting. And it's been really interesting to track their growth, which has been growing faster than basically all the rest from a file type, has become one of the fastest growing malware components that we see out there in the industry. Again, Wildfire created an interesting set of lessons for us and for the industry in terms of how do you do machine learning at a global scale? How do you analyze and make decisions very, very quickly on massive data sets? And what I'm going to talk about as I finish off with Evolution 2 and talk about Evolution 3 is really about big data analytics, about machine learning, about algorithmic defensive postures. A lot of lessons learned here on how we do that on very, very high scale and how we use machine learning, as Mark said before. How do we bring, he says software, I always say computers. How do we bring computers to a computer fight? There's no people involved in this. Right? We're finding over 300,000 brand new pieces of malware on a monthly basis with no people touching anything, updating all of your security postures at the same time. That's a modern approach. Now, Autofocus takes all the smarts of everything we've learned in Wildfire, and it gives you the teacher's edition textbook. Right? I remember when I was back in school, my textbook would be this tall, and the teacher's textbook was this tall, because my teacher's textbook had all the answers in it. Autofocus gives you all the answers. Right? So you have a piece of malware in your network. You want to understand more about it? Well, we have over 5 billion pieces of recent, current malware in Autofocus. We can tell you all about them. What's their indicators of compromise? What's their C2 infrastructure? How often do we see them? Our threat researchers live inside of Autofocus, so Unit 42 tags malware. So they'll actually tell you what is this malware associated with an attack campaign, are others making use of this? So you don't have to do all the research. You get the teacher's edition, which makes you look really smart. You understand what's happening. So these tools in the cloud to create this feedback loop helped us solve one of the biggest first problems I think we had to deal with was how do we deal with the unknown malware, how do we deal with unknown malware, how do we deal with exploits, how do we keep the files that are going to try and get in your network and breach and steal credentials and steal content, how do we keep them out of your network? So we took this machine learning algorithm to deal with malware and did it on a global scale. The new challenge, well, it's always been part of the challenge, but then how do you take a global perspective, but how do we apply it locally just to you? The attackers continue to get more interesting. They're like, all right, my malware has a shorter lifespan. I need to find more interesting ways to attack a network. I need to use social engineering to harvest and steal credentials and invade a network without malware so that I'm not detected as I come into the network. So as Mark said, there's about 1,000 different vendors sitting at RSA any given year, and most of them are actually machine learning algorithmic vendors. And they do some really interesting work on your data to tell you what's happening just in your network. Not globally, how do we find all the malware out there, but locally, what's an anomalistic set of network traffic in my environment that I need to take action on? So this is really interesting. And if Wildfire is dealing with a malware threat, how do we deal with the credential or active hacker in my network threat? And so this world is really about machine learning and algorithmic work just on you and what's happening in your environment. The challenge this industry has had is getting access to interesting, contextual, refined data over a long period of time so they can look at trends, figure out what's normal and what's abnormal, and help you make that diagnostic detection. Many of these tools have been processing on 2 small pieces of data, which gives you a lot of false positives. And while the tool might be interesting, you stop using it because it becomes a waste of time. Or the act of actually bringing them into your network takes a lot of work. Because every one of these interesting vendors says the same thing to you. I have this really interesting machine learning algorithm, and it can really help you. And the first thing you've got to do is just deploy my probes all over your network so I can gather all the rich data that I need to see, and then we can do the analysis. And so you pick the most interesting vendor out there in the industry, and you spend 9 months getting all the probes deployed properly and start looking at the algorithms. And about 6 months into it, a new machine learning algorithm comes out which is even better. But it has a different set of probes and a different decision for you to make. And that life cycle of trying to figure out which algorithmic technique is going to help you the most is undercut by the amount of time it takes you to implement. So you spend a lot of money and take a lot of time in the traditional way we're used to thinking about security to try and gain that insight. But by the time you get there, the innovation curve of the machine learning companies is so fast that you're behind the curve before you get deployed. That's an interesting challenge and something we haven't had to deal with before. So the whole act of gathering the data, determining the analytics, and analyzing what we're seeing to figure out what to contain, where to act, what's that feedback loop, if you will, into the network, is taking too long. We've got to do this in a smarter way. We've got to give you the ability to choose the right algorithmic tool, because each one of you may have a different set of concerns about your network, and what you care about today and the problem 6 months from now could be very different. You need the opportunity to move between tools as you move between risks. So that's where evolution 3 comes in, is how do we take all of the things we learned about a machine learning global feedback loop and apply that locally just to you, to give you access to all that machine learning on your infrastructure. So part of the challenge with that is, first, how do we gain access to the data? So if we're giving you network security, endpoint security, and cloud security, not only are we an enforcement point to secure your infrastructure, we're a probe. We're a sensor. And so if we can log the right information and capture that over a long period of time and correlate the network insights, the endpoint insights, and the cloud insights, the machine learning algorithms can run against this and spend all of their time doing algorithmic work, not spending all of their time trying to deduplicate disparate logs from independent products that don't know anything about each other. And as you're trying to, you need a good data set to do good machine learning. So we've learned that you need to have interestingly refined, curated data over a long period of time, and the algorithms you can build become really interesting then. But more important, if your sensor is an enforcer, your machine learning can now actually act in your network. Probes, by their very nature, are passive. They're tap. And so if you've got the most interesting machine learning algorithm getting all of its data off your probes and giving you interesting insight, in the end, what it's doing is creating more work for you. Because it's going to take a whole set of logs. It's going to distill them down to a set of problems. You're going to analyze those problems and go, yes, there are 6 problems in my network I need to act on. Then you're going to swivel your chair and try to figure out what are you going to do manually to act in your network. Well, that looks a lot like that first slide I had with all the independent security products that don't talk to each other. There's a fundamental gap in operationally, how does that work for you? So in this architecture, if the sensor is an enforcer, if you trust what you get from the algorithms, allow them to act and change your network security posture. It's the exact same thing we figured out how to do 6 years ago with Wildfire, to real-time change your security posture based on malware. Why shouldn't we be doing the same thing based on credential or hacker problems in your network? But you can't do that if the sensor and the enforcer are independent. And back to the whole feedback loop protocol work, we can talk about SDN and NFV. Find me the protocol where some third-party machine learning algorithm is going to update all the right parts of your network from a security point. You've got a DevOps team, perhaps, in your organization that can work to put that together until the next rev of code comes out from the different vendors, and you've got to redo your DevOps function. Right? But again, that's putting the burden back on you to make that happen. We need to figure this out operationally and how to make it scale. And if we do this right, if we're giving you all the right protection and gathering the right analytics for you, we can build some interesting machine learning algorithms. But as Mark said, as we open this up to the rest of the industry, third parties, or even you yourself with your DevOps team, can write really interesting algorithmic solutions to solve for a variety of problems. And I'll talk through some of the third-party solutions that we've already seen come to market here. Because it's not all just about finding a hacker in your network. It may be about profiling IoT devices. It may be about understanding anything connected to your network and what it's trying to do. It may be just visibility and awareness. There's a lot of problems that we can solve if we have insight to the right data. Visibility has always been the first step in security. Bringing that visibility and that analysis to your world versus the global world is key to what you can do in your network. So one of the first examples of an application that lives in this world we brought to market ourselves called Magnifier. What Magnifier is trying to do is to say, listen, we just processed 50,000 logs from your network, and we want to take a computer to a computer fight and say, from those 50,000 logs, here's 3 things to look at. 3 things that we think are a problem. Now, the first one might be your DevOps team is doing something crazy. They've been writing some software, and it's behaving in a strange way. And you look at it pretty quickly, and you go, well, that's actually not an attack. It's just the crazy guys that I hired to help me solve problems are being crazy. OK, that's not a problem. The other 2 might actually be, the first one could be a malicious employee who's trying to steal data. They have all the credentials they're supposed to have, but they're actually trying to steal data from you. You can see them doing what they're not supposed to do that. The second one could be somebody with stolen credentials. You've actually got an attacker in your network. But taking a computer to a computer fight to say 50,000 logs, none of you can process 50,000 logs. But if I can have the computer process the 50,000, tell me what to pay attention to, now as a person, I can decide what's really, really interesting. So distill it down and get a refined view of what the problem could be. So Magnifier, again, was one of the first things that we built to help give that computer intelligence to what it is that's happening just local to your infrastructure, working off of that refined, curated data. Now, in the app framework, Mark mentioned we've had about 30 different partners who launched with us. The partners that are working with us in the application framework are showing up in a set of different categories. And this is just the beginning. As Mark said, if you fast forward a year from now, and we have a couple hundred partners in here, we'll probably have more categories of things that are interesting. I heard our dev team is actually working on Alexa integration with the app framework. I have no idea what good that is, but how'd you like to ask Alexa what's going on in your network? Or maybe Alexa's listening to you all the time, who knows? But how do we think about different problems? How do we do malware detection? How do we do different advanced analytics? Visualization and reporting. How do we find IoT problems? How do we perhaps identify where IoT devices are, profile them to see what's happening on them? But how do we use that same data set to solve multiple different kinds of problems for you, give you greater visibility, or allow you to build different, more interesting feedback loops? If I integrate with identity solutions and I find a problem with an endpoint, I can knock them off the network simply through identity assertion revocation, right? Or I can enforce MFA, multi-factor authentication, for somebody that I'm finding suspicious, because if I've got stolen credentials but I don't have the token, I can't act anymore. Create these automatic feedback loops to enhance your security without you having to do all these things manually. So a couple I was going to highlight. Here's a set of vendors who have really interesting analytics tools that will work off of your data, and they'll actually work off of the Wildfire Autofocus insights that we have in conjunction with their threat intelligence that they have to give you advanced insights to what might be happening in your network. To do similar to what we do with Magnifier, and give you the right kind of visibility for what's important to you. And whether Magnifier is interesting to you or one of these vendors is interesting to you, we don't care. We want to make sure that you're able to prevent a successful breach in your infrastructure using the most relevant tool for your network and your concerns. So these vendors all have the same problem. They need access to lots of high-quality refined data. We can provide them lots of high-quality refined data and give you the opportunity to choose them in a SaaS-based world versus a multi-month procurement-based world. How interesting would it be to turn one of these vendors on for a month, see what you learn, and say, you know what? That one's really, really interesting to me, and I'm going to keep that vendor in my network because they've immediately proven their value. And you look at the next one, and you go, not as interesting, right? I didn't get the insights to my infrastructure that I wanted from that vendor. So while it might be good for some other company, for me, this isn't good. But if we SaaSify, if that's a word, I'm not sure, but if we SaaSify this machine learning access and give you flexible ways to play with and learn and evolve, because this set of icons could change very rapidly, and 3 months later, there's a whole new machine learning algorithm, which is better. You now can immediately switch to that and gain all the benefit without doing anything to your infrastructure. Here's a set of vendors that help you on the SecOps side. Right, so if your SOC is trying to understand about malware-based attacks, credential-based attacks, what's happening in your network, and you're trying to process all of this, how do you do workflow automation? How do you do advanced visualization? How do you correlate all of this together, maybe with external third-party feeds, so that you can get a consistent view of what's happening in your network, and you can actually workflow your responses without doing it manually? Right, since ServiceNow can extract all the information from this, pre-populate all the data, cross-check it with other apps, and so not only is the app framework allowing you to communicate with your data and your infrastructure, the apps can now talk to each other, right, and share insights. So you get, again, flexibility and operational simplicity. Right, I have this conversation when I talk to service providers all the time. CapEx is a problem. We have to think about how expensive things are to deploy on our network. OpEx, operational costs, that is everything. The more we can computerize and reduce your operational burden and automate what you're trying to do, the better it is for all of us. These tools help us make that happen. And finally, if we wanted to focus in on IoT, if you're in healthcare, Medigate might be very, very interesting to you. If you're not in healthcare, probably not. Help you understand medical devices. How do you profile them? How do you manage them? How do you see if they're still secure? Right? How does CyberX help you understand different IoT threats? How do you profile IoT devices in your network to see if you've got a profile of a known device that can be hacked or can be owned with a Mirai-based attack versus other devices that currently aren't known to have that problem? You can correlate that insight with all of the insight we can give you from a malware command and control perspective to see what has been breached, what has been hacked in your network. But this can give you advanced insights that otherwise would be really hard to try and figure out how to get in your network. So those are just a few examples. These are the first 30 vendors who launched with us last month at our Ignite conference who are part of this framework. And as Mark said, there are many more in the loop behind us who are looking to be part of this framework. And I think this is going to be similar to what Wildfire was 6 years ago. Right, when we started on the Wildfire path, to use the cloud to search for malware, to find malware, to globally find it and locally update it, that didn't exist. That was weird. And there's a lot of interesting conversations we had with many people as we went down that path, because the way we found malware back then was local. And of course, as we all know today, that doesn't scale very well. I think this framework is a really interesting path to give you the ability to find all the advanced tools that you need to solve your problem in your network so that it's not complex for you any longer. It's not operationally challenging. It's not based on swivel chair management, and it's not running off of independent data. We need more independent security elements. Like, we need a hole in the head, right? None of those things make sense. Right? We stopped building independent security 7, 8 years ago from a network enforcement perspective. We need to not build independent security as we move into the next generation of algorithmic and machine learning-based defenses. These all need to be connected. If we connect them well and we automate it and we create those feedback loops, we simplify your world, and then we make it exponentially more difficult for the attacker to be successful in your network. And in the end, that's the goal. Right, so that's a bit of a view on the 3 evolutions and really the latest interesting innovation that we see happening in this space. And I do think the app framework and the vendors that are going to be part of the application framework are going to be really interesting components of giving you insight and awareness and knowledge about what's happening in your network moving forward. Thanks for your time today.